All right, hi folks. These are the video solutions for assignment number 18. All right, let's look at problem number 4. Notice that here it says give the solution. So what I'm going to do, I'm going to work it out completely and find the general solution. Okay, so let's go there. This is problem number 4. All right, number 4. And it says sine squared theta equal to 4 minus cosine square theta. Okay, so first of all, remember that sine squared is 1 minus cosine squared, or by the way, cosine squared is 1 minus sine squared. I can use either one of these to get rid of the other one. So let's say that I use this, okay? I'm not going to use that one. So it's going to be 1 minus cosine squared theta equal to 4 minus cosine squared theta. Okay. There's a 2 here. There's a 2 here. I forgot. Right there. Okay. So let's do a cleanup here. For example, add 2 cosine squared to both sides. So if you add 2 cosine squared to both sides, on the left side you're going to get cosine squared theta. And subtract 1 from both sides, so you're going to get this. Is that right? Let's make sure that we didn't make a mistake here. That was my equation. Great. And sine squared is 1 minus cosine squared. I wrote it. 4 minus that. Now I added 2 cosine squared to both sides, so it gets rid of this. And on the left side, you get cosine squared. And subtracted 1 from both sides, you get this. And you have cosine of theta equal to plus or minus root 3. So basically, you have to patiently solve 2 problems. One of them is this. The other one is cosine of theta equal to minus root 3. Do patiently these basic trig equations. Now, I'm not going to do that, and I will leave it to you to do, but I also want to point out this has to be done using calculator, because notice that I do not recognize an exact angle theta whose cosine is root 3. So patiently use your calculator to find cos inverse of root 3. And we have done problems like that. I will leave it to you to go and review it. Go back to homework number, okay, this is 18, then you go 17, 16, 16, 15 and 16, and see how we solve problems like this, cos inverse of minus root 3. Okay, let's do another one. So getting it to this point is important. From that point on, you have to solve the basic trig equation. Let's do number 14. Number 14 is cosine of theta minus sine of theta equal to 1. Okay, so what I did is I did a problem like that in class. I squared both sides. You'll see why. So cosine of theta minus sine of theta squared equal to 1 squared. You FOID this thing, cosine squared theta plus sine squared theta minus 2 sine theta cos theta. equal to 1. Okay. However, this is 1. So 1 minus 2 sine theta cos theta equal to 1. The 1's cancel from both sides, and we have 2 sine theta cos theta equal to 0. And that means we broke it down into two problems. Sine of theta equal to 0, cosine of theta equal to 0. Patiently do these problems. Now, these can be done analytically or exactly without a calculator. This is why I want to do that. So let me start with, let me do this thing. Solve sine theta equal to 0. So immediately I get theta equal to 0, and then we have theta equal to pi. These are two solutions in the interval 0 to 2 pi, which is a single period. Okay, so therefore, the general solution, take these two solutions, add multiples of 2 pi to it. The other one, add multiples of 2 pi to it, where k is equal to 0, 1, 2, plus or minus 1, plus or minus 2, etc. So we did the first problem, this one, we did this one. Now I have to do that. So let me see if I can add another page here. Insert, blank page. I don't know why it always goes to the top. Okay, the other one is cosine of theta equal to 0. And our job is to find two solutions within a period, single period. So find, let me write it like that. Find two solutions in the period, in the interval 0 to 2 pi. That's easy to do. You know what two angles are. Theta equal to pi over 2 and theta equal to 3 pi over 2. Notice that this angle, this point, that point, this angle, and that angle, one of them is pi over 2, the other one is 3 pi over 2, and they're within the interval 0 to pi, which is a single period. So general solution, theta equal to pi over 2 plus multiples of 2 pi, and theta equal to 3 pi over 2 plus multiples of 2 pi. K equal to 0, plus or minus 1, plus or minus 2, etc. Now notice that the first problem, the reason I didn't do it is that I could not figure out exactly what the angle theta was, which was corresponding to, I think it was root 3, right? It was root 3. That's why you have to do it with the calculator. I didn't do that. Okay, so let's go ahead and do number 12. Number 12. You have tangent of theta minus 3 cotangent of theta equal to 0. Now remember, this is tangent of theta minus 3 over tangent of theta equal to 0. And if you multiply both sides by tangent of theta, you get tangent squared theta minus 3 equal to 0. Or tangent of theta equal to plus or minus root 3. And I'm going to do this problem for you completely, okay? So patiently solve two problems. One of them is tangent of theta equal to plus root 3. The other one is tangent of theta equal to minus root 3. And let's do that one at a time. So let me do this one first. Tan theta equal to root 3. Now notice that we need to, when it comes to tangent, you find one solution, theta equal to pi over, okay, this is pi over 3. And this is the only solution in the interval 0 to, let me write it like that, not 0. Let me write it as minus pi over 2, sorry, 2 pi over 2. Okay? Because minus pi over 2 or pi over 2 makes a single period, one period. Okay, look at the difference between the two ends. Its endpoint is pi, it's pi. And therefore, once you get this, then general solution is just take that and add to it multiples of pi, multiples of the period. The period is pi. K equal to 0, plus or minus 1, plus or minus 2, etc. Now let me do the other one. This fellow, I have to do this fellow now, again patiently. So let me erase all of these things. All right. So the other one is tangent of theta equal to minus root 3. So theta equal to, even if you use your calculator, you're going to get theta equal to minus pi over 3, minus pi over 3. Note that minus pi over 3 lies in minus pi over 2 and pi over 2. And this is a single period because the length is pi, right? From minus pi over 2 to pi over 2 is length. So we found one solution in the interval which defines one period, okay? So now the general solution is minus pi over 3 plus multiples of pi because we're dealing with tangent. Where k is equal to 0, plus or minus 1, plus or minus 2, etc. Let me also show you geometrically what we have done. The graph of tangent in the interval minus pi over 2 to pi over 2 looks like this, okay? Remember, this is stuff from 3 to 4 weeks ago. Now, the graph of the tangent, once you draw it in all the period, it's going to go like this, all right? Okay, so what we did is we actually, we were told that tangent is minus root 3, so say them somewhere down here, okay? So this is minus root 3. What we did is we found that solution, this solution, which happens to be minus pi over 3. So we found this. Now, if you add pi, you're going to get this one, and then the next one, and you subtract pi, you're going to get this one, and the next one. So that is what does when you add multiples of pi to it. You go to the right by pi units, you go to the left by pi units, and you pick up all these solutions, all the places where tangent intersects that horizontal line, this horizontal line. So this is what we have been doing. All right, I'm going to stop this thing and go to the other box in a second.